Yeah, so how you all have been doing this 1 week? You completed which lecture? Week 4?
A fourth one in.
Sorry? Hello? Hello?
Hello. Yeah.
Yeah. So, which lecture did you complete? So is it?
Yeah. Like the fourth is in progress. We
Okay.
completed fourth.
Okay. So I guess you have already submitted your assignment number 3, right?
Yes. Yeah.
Okay. Fine. By the way, this coming 6th, I guess we have a class. So 6th, I will not be taking. I think you will get a notification from PMRF that it will be on 10th. Okay. So it will be on Saturday, 7 to 8. So September 6th, I don't think there is any class. So I mean there is any TA session. So it will be on 10th. Okay. Just keep that in mind.
Okay.
So
Hello, I have a doubt in assignment 3.
yeah.
Hello, can you hear me?
Yes. You can tell me. Yeah.
Yeah, I have a doubt in assignment 3, question number 7.
Just hold on. Let me open it. Just hold on.
Yeah.
Week 3. Yes, tell me.
Is the answer 3 or 10?
For which one? Which question?
7th question.
It is 10, right? Because it is 10. There are 10 bits.
Okay. Is it not like 10 divided by 2 and then 5 divided by 2?
No. It is not like that. See,
Okay.
for successive approximation method, the number of cycles is n. For other methods, the number of clock cycle is 2n, 2 to the power n.
2 to the power n. Okay. Successive approximation. Okay. Maybe I have noted it down wrong.
Okay.
Are you sharing the screen, sir?
No, I am not sharing the screen. I'll share the screen in some time. Yeah, any other question for assignment 3? Okay, so we'll go to week 4, right? In week 4, we will try to see the lecture materials. And do you have any questions from week 4? I guess you are already going through the questions of week 4, right? Or I mean the slides of week 4.
Sir,
Yeah.
one question, sir.
Yeah.
In STM32, sir, whether the analog pins can be used as both input and output, sir? No, sir.
In STM?
STM32 board, we are having the analog pins.
Correct.
Okay, sir.
Hmm.
It is only for input purpose. For output, we are using the PWM out.
Yes,
Is it correct, sir?
yes, see, the correct way of understanding is, for example, if you see one ADC, okay,
Ah,
then it is an input. Okay, if you see a DAC,
ah,
digital to analog converter, then it is an output also.
ah.
Okay.
I understand that, sir. In Arduino and all, we can program the pins as input and output, no, sir. Digital pins as input and output.
Right, right. No, digital pins you can configure as input and output, but
Ah, ah,
analog pins are different because
ah,
you can. Correct.
is there as analog in class, there is analog out class, sir?
I don't think so.
Ah, okay, sir. Okay, sir.
Okay. So I'll just share my screen. Mm, just hold on. You're able to see my screen, right? Just let me
Yes.
know if you're not able to. Yeah. So any questions in week 4 so that we can directly jump to some questions of week 4. I'll not solve the assignment 4 because I was told not to do that. But then we have some other questions of same type. So it will help you in solving your assignments. So we can discuss through that. But before that, any questions? By the way, how many of you are planning to buy the board? Anyone?
Arduino.
Is there another versions of STM32 boards?
Yeah, you can buy. See, these are just one type of boards, but then as long as embed OS supports it, you can always buy. But I would suggest to keep the same board. The reason for that is because whatever problems or whatever statements sir is making, then you can directly relate while working on that board. I would suggest that. But if you want to buy something else, yes, you can buy.
The same code and all will work with it also.
No, not exactly. I don't know whether sir is providing any code or not, but I mean, there are some already available boot codes for other microcontrollers. So you can put that and just switch on the board. You can do. But I would suggest to keep the board same, okay, so that you later don't run into some problem.
Yes, because there are cheaper boards in the market available.
But anything which is cheaper than Arduino Uno, you can at least buy that board, no? Arduino Uno is how much? 2000 or 2500 something?
No, Arduino is cheaper, but STM board is a little bit.
Arduino is 200 rupees, sir.
Acha. And then how much is the STM board?
STM will cost you somewhere around like 500 to 600 rupees.
No, board.
Entire development.
No,
board.
no, it is about 1000, some 2000 like that.
Or maybe you
Brother,
are
why
checking.
don't you buy and send us them? Because it's really costly out here.
I can do it because in SP Road, right, in Bangalore, there is electronics market. So there you will get it for 600 rupees.
Okay, brother,
Arduino.
so can you give me your contact number so that I can contact you for that?
Yeah, sure. I'll post it in group. Okay, if you guys want, you can let me know.
Okay,
I
brother,
can
can you
buy.
give me, where did you post it?
I'm posting it. I'm posting it.
Yes, post it because it will be really helpful.
Yeah, excellent, Chetan. Thank you.
Even sensors
Is
also.
it the same board mentioned?
Yeah,
Here?
same board. I already have bought it, and I mean 2 years ago, I had bought that. Arduino will somewhere cost you 200 to 220 rupees, and STM32 I bought it for 600, I guess. 600.
Okay, okay.
And sensors you will get it for 80 rupees, 100 rupees, and all this kind of.
Sir,
So
you give the
does it
address
ship?
Address,
so that we can also bought from the same.
ma'am, you can check it in Bangalore SP Road.
Okay. Is Bangalore?
Bangalore, you can type SP Road. So you will
SP
get SP Road.
Road.
SP
Okay.
Road. There are few shops over there. You can easily get from there.
Yeah, one of the shops is NSK Electronics.
Yeah, NSK. I mean, he's a person who will deal more with PCB designs.
Correct. No, but they also have boards, no?
Yeah, even they too have both. They too have both.
Just
But
we know because NSK Electronics has got a website.
yeah,
So
website.
maybe, yeah, you
You
guys
you
can check there.
you can also check with Om Electronics or Vishal Electronics.
Home
S
electronics.
SP S
ST Road.
S for super,
Ah,
P for parrot.
SP Road.
SP
Okay.
Road. SP Road. You can get it very cheap. You
Okay.
will get, and I mean all the components.
Okay,
Usually,
sir.
usually, sir, you are from Bangalore only, no? You stay in Bangalore.
Yeah. But right now, I mean, yes. I mean, I moved from Bangalore to Kolkata like that.
Oh, okay.
Sometimes I'm in Bangalore, sometimes I'm in Kolkata. Like that.
Okay. The people who are from Bangalore, in Chennai also you will get. In Chennai also for the same prices.
Okay, sir.
Yeah.
So does online booking it supports like shipping is available in that?
That I'm not sure. But if you
Okay.
buy component from that shop, right? And if you ask
Okay.
him, if you pay him through online, he will ship you,
Okay.
but he will charge you the courier charges.
Okay. 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 Got
Yeah,
that.
that would be minimal only. But I'm
Okay.
not sure whether you can courier these things in normal courier.
Means I have to just contact him and discuss it with him.
Yeah. I have shared you my WhatsApp number. Right,
Okay.
you can text me, and I mean whoever wants any components, you can tell me. I will buy it and I will courier you.
Okay, sir.
Okay.
Okay then.
Yeah.
Thanks, Chetan. That will be of great help.
It's okay.
Yeah, it will help.
Yeah. Thank you.
Hey, one question I have like after buying the board, how should I check like whether it's faulty or it's working correct? Is there any?
Yeah, the correct way. See, for if you buy, there are many example programs. Okay, you just program and
Uh,
see whether the LED is blinking or not. That is sufficient.
okay.
For example, if for example in microcontrollers in ICs, what happens is it is not that portion of the IC will go bad and some portion will be correct. So if the IC goes bad, everything most probably everything will be bad. So if the LED blinking is working correct, then your other portion of the controller will also correct. What be it PWM or analog. Okay. So just try out the blinking LED project. Blinking LED is working, then the board is correct.
Okay. Thank you.
Okay. So yeah. Uh, mm, so should we go to this? Yeah. Any questions on all these slides? Week 4.
I was trying to install the drive,
Which
STM
one?
drive, but it's not installing. Can you
Which
help me
one?
out with that?
Which one were you trying to install?
This one ST. Let me tell you. Whose link is given in that lecture material.
Acha, okay. Maybe then what you can do is you can post in that discussion group of yours.
Actually, the thing is that I have downloaded it, but the problem is that it's not. It's a zip file, and it's not opening. I don't have any. Do you know any software to open it? Because lastly I had WinRAR, and now it's asking for subscription of something like $30-40.
Oh no, because WinRAR is most of the time free, no? What you do is you download
That's the case. That's the case. Right now, when I opened it, WinRAR was asking for money. That's why I didn't didn't subscribe.
maybe what you can do is uninstall WinRAR and install it again from
Yeah, I did it. I did it, and still it's not working. Which website did you tell? Which website was that? Could you please repeat?
Are you asking me or Chetan?
Sir, you are saying that install from
Oh, acha,
somewhere.
acha. Soft tonic, something
Soft.
like that. What you can do is right now just say WinZip download.
Yeah, WinZip I installed, but I don't know how that works.
Oh,
So like I have unzipped it, but I don't know where it went, and I can't see those files now. I can't
acha,
access to those
acha.
files.
Okay, okay. Then maybe what you can do is you can post in that discussion group.
Oh,
Okay, just post it there that I'm not able to install it. What are the files? Because sometimes what happens since websites may get obsolete. Okay, so
okay.
The link Chetan posted is something different.
Sir, is that the development board which I posted is correct?
just
Because I have that only.
let me see.
Yes, sir. I mean, this is little bit newer version. What this whatever I have posted is little bit new version. Mine was little bit old.
No, this is not the one. No,
Maybe
you are
just
saying this one, right? You can
yeah,
see my
yes,
screen,
sir.
right?
Yes, sir. Yes, sir.
Yeah, not this one. What you have to download is the one. I think.
No,
Yes.
no. Is that board correct, sir? Because it is the same thing.
No, but this is
I
nuclear, no?
so I
Oh, this
think
is
it's
nucleus.
mentioned in the
Okay.
second lecture. It's mentioned in the second
Yeah,
lecture.
this is the board, no?
That
Nuclear
Okay,
board.
driver,
nucleus. Okay.
that driver is mentioned in the second lecture, I think.
That cost
I think
3,000
this is
something.
the board. This is the board.
Yes, sir. Yes, sir.
Yes, sir. On the original website, it is showing about 3,000 something.
Yeah.
Okay, I'll check this and I'll let you
Yes,
know
yes, yes.
the
Better.
price.
That's why I asked him to buy.
Yeah. I will check this price and I'll let you know. Okay.
Yeah.
Yeah, sure.
So yeah, we'll get back to the slides. Any questions on this? So if there are no questions, I would directly go to maybe the assignments. Is it okay?
Hello?
Hello?
Yes, sir. Myself, Shubham.
Yes. Hi, Shubham. Hi.
Yes. I just wanted to ask like this in Arduino,
Hmm.
it is when I went to the online website and I looked at the documentation,
Hmm.
there it was in the documentation it was written that it follows a similar syntax like C++.
No. It follows the syntax of C. See that there is not much difference between C and C++. Okay, it is only the
Okay.
instantiations and all those things which are there in C. There are some extra features in C++. So,
Okay.
but for embedded programming, there is not much difference between C and C++. What Arduino website says is that Arduino coding is mostly object oriented. Okay,
Okay.
so object oriented means you can instantiate some of the objects and then you can call. So, but there is not much difference between C and C++ in the embedded environment. There
Okay, sir.
okay, so don't worry about that. You can, if you know C, that is sufficient.
All right, sir.
Okay.
Yes. And the same is for
STM.
STM32
Yes,
also, right?
absolutely.
Okay. Okay, sir.
Okay, so we will directly go to the questions maybe. Yeah. So first one, you know about what is a duty cycle, right?
Is it a fourth week or some other week?
Can you mute yourself? I can hear some background noise. Yeah. Are you able to hear me?
Yes, sir. Yes, sir.
Yeah.
Yes,
So
sir.
you know what duty
Yes,
cycle is,
audible.
right? Hmm?
Audio.
I'm not able to hear you. Hello?
So you are
Audible,
audible.
sir.
Sir, you are whatever you are saying, like you said hello right now.
Yeah, you're not able to hear me?
Audible, sir.
I
Okay.
can hear you, sir. You are audible.
Yeah. So first question, see duty cycle is, for example, if you have a pulse like this is your on time and this is your, let's say, off time, and this is your total time. Okay, total time is on time plus off time. So duty cycle is on time divided by total time into 100, or on time by on time plus off time into 100. Okay, this is called as a duty cycle. So a wave with higher duty cycle means there is larger on time than the off time. Okay. So with that, can you tell me what is the first answer?
Option B.
Option B.
B.
Okay, how did you calculate it?
Yeah, it's T1 upon total time into 100. It's 9.09%.
Okay, fine. Then question 2. Acha, question 1, did anyone have any problem?
No, sir.
Okay. Question 2.
One and two. One C.
Correct. Question 3.
Option third भी correct होगा ना, I think, sir.
SRAM. I think it has less SRAM, no?
128 kVA.
Does it say 128 kb? 196 kb?
512 kb.
No, 512K is correct.
It's
What we can do
96.
is process. This
96.
SRAM is 96 or 128?
96, sir.
96.
96.
Okay, so A
Yes,
and B
yes,
are
yes.
correct, right?
96, sir.
96 is correct.
So A and B are
RAM
correct.
is 96.
Okay, question 3.
And flash memory is 512 KB.
I'm not able to
Option A
hear
and
you.
option B.
Option A and
A
option
and B.
B. Wait. A and B. Right. Question 4. Just hold on. Question 4.
EC.
B and D.
Someone is saying B.
B and D. B and D.
C as well.
Its
Correct.
clock speed is up to 10 megahertz, no?
Arduino, you know.
Yes.
Just check in your internet Arduino Uno
Can
specification.
anyone explain what is this 80 mega 382 microcontroller?
So this is a microcontroller actually. So what it says is Arduino Uno is a board, right? In that you have a small microcontroller. So at the name of this microcontroller is Atmega. Atmega 328. Okay. Now there are other things like LEDs and then connectors and all, and this is a total Uno board. And in this UNO board, this is the microcontroller. This portion.
BCD.
Correct. BCD.
Even C is also correct.
Yeah, BCD. So, whoever asked the question, what is Atmega, was it clear?
Yes, sir. Yes, sir. It's clear now.
Okay, question 5, just hold on. I'll see whoever is there. Yeah, question 5.
Request, can you zoom this document?
Yes, sure. I'm very sorry. Yeah. No?
B and C.
Yeah, it's
Sir, option B and C.
Correct. Okay. Question 6.
Option A.
Option A.
A, 1.25 seconds.
Hello, sir.
Question
think B.
7.
A, B,
Sir, option B.
A,
A
B.
and B.
Okay. But before that, I will ask you something. See, why did you say option B?
Only option A.
Only option A, sir.
Option B. Option B.
On duration 400 milliseconds, sir. Off duration 600 milliseconds.
Okay, this one is okay. Someone is saying. Why not option A?
Sir, option is also correct.
Duty cycle. A is also correct. Duty cycle 40.
Yeah. So, but right
0.4
now.
by 1.
Sorry.
4 by 6 into 1.
Correct.
1.
No, not 4 by 6. Not 4 by 6. 4 by
0.4 divided by
0.4 by
1 into 100.
4 divided by 10 into
10 is 100. 100.
Okay? 4 divided by 10. But no one has asked me. See, there is a catch here. No one has asked me whether 0 means glowing the LED or 1 means switching.
1 means blowing the LED. 1 blowing the LED.
Yes.
And 0.
But how do you know that?
1 off state. 1 on state.
No, but how do you know that? For example, let's say that this is my microcontroller pin, okay? And I have put a LED like this.
Common cathode.
Correct, 5 volt.
The pin should be at 0, low level.
Yes, if it is a
0
0,
is
then only it will glow.
the LED
If
will
it
glow.
is 1, then LED will not glow. So when you say that yes, blink LED, right now here you have considered that 1 is on and 0 is off. But it can be the other way around also. Okay, so the question as such is none of these are incorrect because the information is not provided.
In which how is correct?
Okay, that is very important because if I tell you, because I have mentioned here LED on and LED off. Okay, with on duration, but you do not know which one is on.
Okay, sir.
Okay, because you do not know the configuration of the circuit.
So, sir, whenever the question is in the case, then we have to consider whether it is common anode or common cathode in
No,
the
you consider
given
this, for
situation.
example, when you put 1, then it glows. This is what you have to consider. 1 means on.
But sir, default connection should be common cathode.
It's for
Sir,
7
but
segment.
in class,
Yeah.
sir, but
No,
in class
actually-
explanation,
Sorry? Yeah.
sir said in class explanation 1 means it is on, 0 means off.
Correct.
So can we consider that as an example, and can we answer this question A, B, C is correct?
Yeah, so for example, whenever you are not provided this information, then you should consider 1 as on and 0 as off.
So in this case, even C is also correct, no, sir?
No, why? How this duty cycle can be 60%? if you consider that 1 is on and 0 is off, what?
Yes, sir. Yes. Yes, sir. Correct.
Okay. But keep this thing in mind. So
Yes,
whenever
sir.
you are designing circuit or whenever you are working on real world problems, you have to understand.
Sir, wait will give us delay of seconds or milliseconds, sir.
No, you are
Seconds.
giving in here 0.6, right?
Seconds.
This is
Seconds.
So seconds.
yeah,
Okay.
correct. 600
Seconds.
milliseconds.
Okay.
600 milliseconds. So keep
Sir,
this thing in mind.
while
What is the
answering
correct
this sort
answer
of
for this,
question,
sir?
you
Seventh
should
question, what is the
Yeah,
option
just
correct
just
answer?
ask the question one by one, please.
Sir, here it is not given how the LED is connected to the port.
Yeah,
So you are considering the answer as none of this, sir.
correct. So consider this as the default case.
Okay, sir. By default, what is the default case, sir?
Default case, I mean, from the point of view of answering your questions, I mean, if your questions are asked like this, consider this as the default case.
1 means
Then
on,
for
0
this
means
question, A
off.
and B are correct now, sir.
Sorry?
Since they are not represented as a common anode or common cathode, so defaultly we can consider 1 as on, 0 as off. So option A and B are correct. Am I right, sir, for this
Yes,
question?
correct, absolutely.
A and
But
B are correct.
correct, A and B are correct. So these are the correct
Okay.
options, A and B. But what
Okay,
I'm saying,
thank you,
keep
sir.
this thing in mind when you are working on real world problems.
Okay.
Because the designer will design a board and you have to write a code. So first you have to ask the designer who has designed the board whether it is common anode or common cathode. Based on that you have to select.
Yes,
Just
sir.
keep this in
Thank
mind.
you, sir.
Sir,
Yeah, tell me.
which pin in the STM board is the inbuilt LED?
That I have to check that.
LED3, LED3,
Correct.
D3. Yes, sir.
That I have to check. I have not checked the board. LED3 maybe, yeah. But that you will get to know only when, for example, when you buy the board. Hello?
Sir, yeah.
Yes, sir.
Yeah.
Sir, that means question number 7's answer is none of these. No?
No. Actually, what I told is, I mean, actually, you should have answered me as none of this. Okay. But I mean, you followed the default condition that zero is off. So whenever what I'm saying, whenever you are not given the data, okay, which logic state is on and which logic, consider the default case. 1 is on and 0 is off. But if I give you the questions like this, 0 is on and 1 is off, then in that case C will be the right answer.
If it is not given which is on, then what we should do, sir?
Then default case.
Excuse me, sir. 1 is on, 0 is off.
Yes. But I was expecting from every one of you none of these, because I thought that, I mean, you will ask that question. But that's okay. I mean, since you consider the default case. Sir, I think has already mentioned in class.
How will we evaluate this question, sir, if the case is not given?
Sorry.
If such question is asked, what the answer expected by them, sir?
No, same thing. Default. They will be
Default.
expecting the default.
Okay, sir.
Excuse me, sir.
Yeah, tell me.
Sir, someone is waiting in the. My friend is waiting in. Waiting.
Okay, I'll just check. Okay.
Sir.
Yeah.
Sir, my question is regarding the weight function. Actually, I was programming this board yesterday, and I found out that this weight function is no more allowed because it was allowed in Mbed OS version 5. Now the OS version is 6. So here it is not allowed. There is some other functions. So,
So yeah, yes, true. But since they have not mentioned the version of the thing here, okay, which version they are using, so that's considered the old weight. But you can post in the discussion forum that since the new version does not have a weight function, so maybe they can a slide.
Okay, fine. Okay.
Yeah, then yes. Question 8. Any idea?
Sir, option B.
None of these.
Option A.
Option D. But it is printed B, but it is D.
Sorry?
A or B.
None of these.
Acha, why you are saying none of these?
Because this is an Arduino, no sir? Digital out.
Yeah, this can be in STM also, I guess, because they all follow the same nomenclature. No? Because see, you cannot give it a name D4, okay? Option B says give it a name D4, so it cannot be. I think it is option A. I believe that it's option A because you are conferring the D4 line as digital output pin and then you are giving it a name which is called bomb. Okay, so keep this thing in mind. The next question I guess will be interesting. Yeah, question 9.
Sir, can you please explain the previous one once again?
Yeah, so what it says is, right now you can always, what it says, the digital out is a construct, okay, which means that you configure this D4, which is a D4 line, as digital output line, and you can also name it as bomb.
Yes.
Okay, so this is what it says. You can represent this D4 from the next portion of the code as bomb.
Okay. Yes, sir.
Okay, question 9. Question 9 is more of an electronics question, but I'd be happy if someone can do it. Is someone trying? Is someone trying?
Yes, sir.
Okay, good.
The anode is connected to 0 volts.
Yeah, so it is said active low. Active low.
Or active load. So anode is connected to ground.
No.
0.5 kilo.
How much?
Anode is connected to microcontroller.
Correct. Anode is connected to microcontroller. And then you have one resistance here, and then you have 3.5 volts here. Okay. This is connected to microcontroller.
0.35 kilo.
0.35 what?
Anode is connected to microcontroller.
0.35 kilo.
Yes, sir, 350 ohms.
Correct. 350 ohms.
That's what 0.35.
Correct. That's why I asked the unit. Whoever said 0.35 is also correct.
583 ohms.
583. Right? How did you calculate?
Oh, drop is 1.5.
Correct.
Okay.
This drop is 1.4. Anyone having any question on this?
Can you please explain how this happened?
Sorry?
I didn't get it.
Okay. See what happens. Current will, the moment you make it 0, current will flow, right? This current will flow. Now to make this LED glow, 1.4 volt is necessary here. If 1.4 volt is dropping here and this potential is at 0, then what will be the drop here? This is I into R, right? So IR will be 3.5 minus 1.4.
1.4 divided by.
Correct. So this I is given as 6 milliamperes. So 3.5 minus 1.4 is 2.1. So R is 2.1 divided by 6 milliamperes. I guess that's coming as 350. Okay. You got it right?
Yes, sir.
So you have to consider the LED drop here, 1.4. Okay. Now I hope everyone is clear with question 9 because you will get this kind of questions in your exam. Okay? Question 10.
AB.
Value decreases and light falls. I think it's
Light falls on.
Okay. Maybe we'll go to another assignment. Just hold on. I don't know where I have kept my assignment. Yeah. Question 1.
Second and millisecond.
Sorry?
Second and millisecond.
Second is millisecond. And the first one is?
No, option B is the answer. Second and millisecond.
You're saying this, right?
Yeah.
So these are more of a informative based questions. I mean, if you have the information about this weight and delay, then automatically you are able to do this. These are not true. Which of the following are not true?
C.
Definitely C, because it does not have a DAC. Okay.
Answer.
Then
Option D also.
correct.
The analog of that can be used to generate PWM. C and D.
Yes, sir.
Yeah, question 3.
Hello?
Hello?
Hello, sir. Yes, sir. One thing, like in STM and Arduino, both have only digital output. Means in both of them, analog output is not there, right?
No.
Okay. Yes, that I wanted to confirm.
Yeah. Question 3.
Option A and C.
Correct. This is the same as that bomb, right?
Yes, sir. Correct. Same as the bomb.
Correct. Question 4.
Option. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4.
Atmak and
A.
C.
Option A.
Option
A.
A.
Option A.
Sure.
Yes, sir. A. Cortex
No,
M4.
It can be D as
respective.
well. It is D as well. ARM
No,
Cortex
no,
M4
it is
is
Arduino.
D. D. It is D.
Correct.
it's
D.
D.
Ah,
It's D.
Because
Cortex
Arduino
M4.
is
Respectively,
Last.
they are used.
D.
This one is this.
Yes.
Then common LED, common anode.
Anode.
I think favorite topic for all of you. Yeah, which one?
Questions skipped. No? What's the question?
Option A.
We want to blow zero in a common
Option
anode.
A.
Sir, what is answer of
Option A,
question
sir.
number
Lona
5?
one. None
Sir,
of
question
this.
number 5 is skipped.
None of
answer.
this.
Yeah, no. Someone asked me about question number 5. Wait. Yeah, tell me.
5.
6. 6, 5.
Question number 5 is the left.
Oh, 5 is left, huh? Sorry.
Sir, yes, sir.
Yeah, tell me.
To write logic 0.
Sir, option number C.
Yeah. Option A, sir.
Is correct, right?
Correct.
5 low.
A is the correct answer. 5 comma low. Logic 0.
Correct. So first you write the pin number, then you write the state.
Is the state.
Anyone having any question here? So this, even if you are not clear, it does not matter, because once you start programming, no, you will be able to figure this out. Yeah. Let me see whether the recording is on. So yes, question 6.
A.
Anyone is having any question? So it is like,
No, sir.
okay, it is like this. Only this portion is.
G is not, should not blow.
Sorry. Only this is not there. Rest everything is there. So this option is valid. Same question almost.
Sir,
Yeah, tell me.
sir, one doubt is there. Sir, in 7 segment LED, we get H. So what is role of H?
H is for this one dot.
Yes, sir.
Yeah, so H is for the dot. So for example, when you are writing, let's say, so you have something like this, right? So you have all, let's say you want to display 22.3. So 2 will come here, dot will come here, and then 3 will come here.
Okay, sir.
Got it?
Thank you, sir.
Okay. For 8, I think question number 8.
7.
No.
7.
7. Yeah, tell me.
Sir, question number 7 is left.
Yeah, question number 7. Tell me. Sorry. It is almost the same as the last one.
$200.
200.
Anyone having any doubt on this? Okay, I'll move to the next question. For LCD display VE, what is the use of this VE pin? I think it was covered by sir, if you remember.
B.
B.
D. Option D.
D option, sir.
Correct. Question 9. This I think
A and B. A and B.
A and B.
A and B, sir.
A and B.
A and B.
A and B. Yeah, correct.
A and B.
Yes, not A and B. Yes. Question 10. Now set
A.
speed is used for what?
A.
That's
D.
okay. B, okay. So set speed is used for what?
Scrolling.
Serious.
Or scrolling.
Scrolling. LCD scrolling.
Okay. So for scrolling, right?
Yes.
So you see, for example, if it is, I mean, person who said character per millisecond, if you set the speed to character per millisecond, you will just understand, for example, 2 character in 1 millisecond, how much fast it will be. So it's
Yeah, it will do fast. Oh, option A.
Correct.
But I compared it with wait functions.
I got it. Acha, so maybe I'll try to deal with something. I mean, I'll try to explain about. Do you know anything about? Let's say that. Let us discuss, since we have finished before time. So these are the questions that I had. I think you will be okay with week 4. In week 4 there won't be any much problem. And week 5, when you have to submit your week 5 assignment and week 4 assignment?
Week 4 tomorrow.
Okay, week 5?
Week 5 is 31, sir.
When? 31st?
Yes, sir. Next Wednesday.
Yes, sir. 31st.
So maybe next week we can discuss week 5. So before that, can you tell me, sorry, what is this number? What is the decimal equivalent of this number?
Two, three, 4.
29.
4,
29.
29. 29, sir.
29, sir.
Now you tell me, what if I say it is not 29, it is 14.5? Will you agree with me if I say if it is 14.5?
No.
No, sir.
Okay.
How, sir?
Because you have considered this as 2 to the power 0, this as 2 to the power 1, this as
1
2
to power 2.
What if I consider this as 2 to the power minus 1, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, and this is 2 to the power 3. If we consider like this, what will be the value?
14.5. Yes, sir. Yes, sir.
So you see, only if I tell you only a string of bits and tell you that what does this indicate, you will not be able to tell me unless and until I tell you what is the LSB, whether it is 2 to the power minus 1 or 2 to the power minus 2 or 2 to the power 0. Keep this thing in mind because this is a very important concept for fixed point numbers. Okay, you have heard about this term, fixed point numbers?
Fixed point numbers.
Yes. So this forms the basic for fixed point numbers. In floating point numbers, you can go for 2.3333 something. In fixed point numbers, you cannot do that. But fixed point numbers also helps you to represent a decimal number or represent a fraction to some extent of accuracy. And it is very easy to calculate on the hardware. So whoever is doing hardware programming and all, they should know about this fixed point number. So I will not go into detail, but I will just give you the key points that that you can search in internet, that what are these fixed point numbers, or more commonly it is known as fixed point arithmetic. Okay, learn about this. This is a very important concept, and most of the current processors, most of the, even your mobile phones, most of the time uses fixed point arithmetic. Okay, another thing is, for example, tell me what does this, now this is the start and this is the end. Tell me, what does this wave represent? What are the bits that this wave represents?
1010.
In positive logic, it represents 1 0.
Okay, okay. So let's say
1
this is
0.
positive logic. Okay. So this is plus. Let's say this is 0. It's by default. So it is 1010. Anyone else?
Sir, it could also be a PWM signal.
Absolutely. No, no doubt about it. It can be a PWM signal. But what I'm saying, what does this logic represent? I mean, what does the wave represent in terms of logic? You have to tell me numbers. This can be any kind of wave. This can be a PWM wave. This can be a PCM wave. Okay. But you have to tell me what kind of numbers does this wave represent? It's 1010, right? Someone was saying. Two people said 1010. Anyone else who can represent this in some different form of numbers? In binary only? Okay. What if I say it is not 1010, it is 11, sorry, it is 11001100. Am I wrong in saying that?
No, sir. No, no.
No, sir, no.
No, sir.
Someone might say that it is 111000 because you do not know how many zeros are there, right?
Correct, sir.
You do not
There are
know.
no clock cycles.
Correct. So unless and until I'll tell you the clock cycle and what is the bit width, never answer never answer in your real life or in some real world problem. Whenever you see a wave like this in CRO, do not consider that as 1010. Okay, it can be 1100 1100. So to solve all this problem, you have something like return to zero signaling. So this is a problem with this, right? This is a problem with this kind of wave. If you represent 1 with positive volts and 0 with negative volts, then what will happen is you need to have a clock. You need to have a clock information to understand what kind of, how many ones are there in this positive cycle and how many zeros are there in this negative cycle. So there is something called return to zero signaling. Okay, return to zero signaling is like this. You have 1 like this, okay, and you have 0 like this. So right now, whenever you see, let's say I have 1010, I will have something like this is 1, then I have 0, this is 1, then I have 0. Now see, there is no ambiguity now. Because, tell me.
Is this like the clock also changes its polarity, sir?
Yes, actually, you can say that the clock is embedded inside the data. Okay, so this is called real return to zero signaling, because the signal after becoming 1, it is returning to 0. The signal after becoming 0, it returns to after it becomes negative, it returns to 0. So this is the way you find out. So this is the way you avoid this problem. So learn about this kind of signaling. Okay. So I'll tell you some keywords: RZ signaling, Manchester signaling. Okay. So all this kind of signalings are there so that you avoid these problems. Okay. Because the moment you transmit this kind of wave, what happens is you have to transmit a clock also to the receiver so that the clock can decode how many ones are there here. But if you have this kind of signaling, RZ signaling or Manchester signaling, then you do not need a clock along with that. You just pass the data and the receiver will automatically understand how many ones are there. Because in this kind of waveform, you can have only 1 1. In this kind of waveform, you can have only 1 0. For example, if it is 1 1 1 1 1, then it will be like 1 1 1. So the number of negative transitions will tell you how many ones are there. Okay. So just what I'm saying, I'm just giving you food for thought. I'm just giving you ideas. Okay, learn about this kind of signaling, RZ signaling, Manchester signaling, because they are very, very useful in the embedded world. Okay.
Sir, does this come under digital electronics or is another subject?
Sorry?
Does this come under digital electronics subject or is it under another subject?
No, digital electronics. Absolutely. See, I'll tell you one thing. Whenever, for example, Okay, so you are from electronics, right?
Yes.
Okay, so I'll give you a simple example. Uh, you have learned control systems, right?
Yes.
And you have learned about op amps.
Yes.
Okay. Right now, if I give you a circuit of op amp, will you be able to relate to control system?
Directly, I don't think so.
Yeah, but you have to. So the idea here in engineering is, in engineering people, whatever people does is, you give
Hmm.
concept one, you give concept two, you give
Yeah.
concept three as
Hmm.
separate subject. But
Hmm.
actually in real world, you have to combine all the three subjects. So I'll tell you an application here. You know this buffer op amp, right?
Yes.
I'll tell you buffer op amp. This is,
Hmm.
now this can go into oscillation.
Right.
This can go into oscillation following this control system concept. A by 1 plus A beta.
Okay, so we have to relate the subjects.
We have to relate the subject. So similarly, this Manchester signaling or RZ signaling you may find in communication.
Ah, yes, right.
Yes,
Yes.
but they are also useful in these digital circuits.
Hmm.
Okay, so right now is the time when you have to connect all the subjects. It is very important because, for example, when you work on, let's say, some hardware design or when you work on some software,
Hmm.
then you will understand that yes, I mean, the software is just a means of implementing one bigger concept. Let's say filters. Right now, if I say that C and filters, you will say these are two separate subjects because one is software, another one is, let's say, is DSP or analog circuit.
Hmm.
But then both of them are connected because in real world you have to implement one filter in C program.
Hmm. Right.
Okay, so all these things are connected.
Sir, just one thing.
Yeah.
In these type of signaling, the voltage levels will be different, right? We cannot say something. Suppose it's from 0 to 5 volt. Maybe the high logic high will be from 5 to something around 4.5, and the low will be from 3.20. How will be the voltage level for these type of signals in digital?
No, there are many. There are many. You have 5 volt, you have 3.3 volt, you have 2.8 volt, you have, sorry, not 2.8, 2.5 volt, you have 1.2 volts, you have 1.8 volts. Depending on the CMOS logic you are using, all these things will come. So for example, you can have a wave, you say it is 1010, let's say, okay, but it can be actually 3.30, it can be actually 1.80. So it is up to the
So, no, sir. It's how it will be in the RSZ, RSZ signaling, because there will be a voltage level. The wave should be in the downward direction, right? But you draw in anything.
this one you are saying, this part.
Yeah, yeah, this one.
Yeah. So no, this is okay. The reason for that is, for example, let's say it can be 1.8 and it is minus 1.8. Okay.
Oh, okay.
Okay. So it is possible. It is possible. So it becomes a, for example, it becomes a differential signaling. So 1.8 and minus 1.8. That is possible.
Okay, sir.
See, because I'll tell you one thing. You are seeing the wave like this. What if I have two wires, okay? This is positive and this is negative. Once I give a 1 point signal here, let's say 1.8 signal here and 0 signal here, then you get in your CRO, you get a wave like this, right? 1.8 and 0. Correct?
Yes, yes.
What if in the negative line I give 1.8, 0 and the positive line I give 0? What you will get? Minus 1.8 and 0, right?
Yes, yes.
So it is like you are both in the both positive and negative line, you are just feeding the positive voltage. But when you are taking the difference, you are getting something like this. 1.8 and minus 1.8. You got it, right? What I'm trying to say? Or else?
Yeah, yeah, yes. Thank you.
Yeah. So it is based on the differential CRO. You provide 5 volts here and 0, the CRO will detect as 5. You provide 5 volt here and 0, the CRO will detect as minus 5. Or the multimeter. So with respect to what you are measuring, that is important. So when I say, let's say you have, let's say,
Like inverting and non-inverting input.
correct. So you have, let's say, 5 and minus 5. Don't think as if the amplifier is actually, or the output circuit is pushing minus 5. No, it can be that you have two lines and you are taking the difference. So once you give 5 here and 0, you get this voltage, and once you give 0 and 5 here, you give this voltage. Okay?
Okay, okay. Thank you, sir.
Yeah. Whoever is, someone is joining now. Okay. So I guess if there are no other questions, then can we end for the day?
Sir, there is one more question.
Yeah.
I want to ask regarding this embed environment. How relevant it is in the industry? Is it used in the industry?
Embed.
Embed wise.
No, I don't prefer using this kind of things in industry.
Because I've been programming using the bare metal in IDE. So I thought embed may be used in, because I think it is used for IoT applications.
Yeah, embed is used for IoT and mainly for academic purposes, because not everyone, see, in academic purposes everyone is using, let's say, very low end laptops, right? So you may rely more on cloud compilation than on your computer compilation.
Yeah, because I'm also not using that online compiler. I'm using the Embed Studio version.
Correct.
Okay.
But
Okay, fine.
But it
It's
all
for learning
depends-
purpose.
Yeah, learning purpose. But I'll tell you one thing right now: the way it is progressing, all depends on your requirement. For example, to switch from this online compiler to offline compiler, you just do it on a snap. That's all.
Yeah, right.
The idea is that you should be equipped with, or you should be adept with both the compilers, whichever is necessary and whichever you find convenient, you use that. That's all.
Yeah, but the online compiler is retiring, I guess. It's written on the website.
Acha, is it? Okay. Then I
Yes,
don't
yes.
know, because I normally don't use online compiler.
Yeah, right.
Yeah. Good that you have said that.
Okay. Thank you, sir.
Thank you. So, I guess we will call it a day.
Yes, sir.
Thank you everyone.
Thank you, sir.
Meet
Thank you,
next
sir.
week, and then on September 10th. Okay. Take care. Bye.
Good night, sir.
Yes,
Bye.
sir.
Thank you.
Bye, sir. Bye.
Right.